consumer equilibrium. So far, we have learnt two important pillars of microeconomics, the indifference curves and the budget line. The indifference curves maps the consumption of two goods or services at various levels of satisfaction or utility. And the budget line maps another dimension, budget of the household or consumer, which identifies the boundaries of the products and services that the household or consumer can afford to buy. The satisfaction or utility levels and the price constraint are the raw materials which we would now use to build the full jigsaw. Now, we would derive how consumers identify consumption equilibrium patterns that maximize the utility while at the same time remain within the budget constraints. Here we go. Let's draw 4 indifference curves with 4 different utility levels. Now, let's superimpose the budget constraint on this, which maps the mix of the two commodities the consumer can afford to buy. Each point on the budget line maps the combination of two products or services that the consumer can purchase while just exhausting his budget. Now, consider U1 and the products combination between the 2 points A and B are all affordable as they lie within the budget constraint triangle. Any product combination before A or beyond B are out of the budget line and non-affordable. However, the utility levels are lower as is defined by U1, and also the customer or family has not fully utilized his total budget. He still has spare money which he can use for spending. From the customer or family standpoint, he would therefore be looking for a consumption pattern that utilizes his money and also gives him a better utility level. Consider U2. Here the product combination, the utility level is higher and the remaining surplus for him, if he consumes products between point C and D, is lesser than in U1. However, still the consumer would wish to buy more and increase the utility levels in order to exhaust his budget. Consider U4. For this curve, naturally the utility levels are higher, but unfortunately, for getting this utility level, the money he would have to spend for the consumption is higher than he can afford to pay. So, while there is an aspiration to achieve this utility level, he cannot afford it. Now let's consider U3. This curve has a utility level higher than U2, but lower than U4, which anyway is unaffordable for him. At point E of U3, where the consumption level is of the utility level of U3, the consumer is able to afford and also exhaust his budget. Let's spend a few minutes on this point E. This point comprises 9 units of cookies and 4 units of brownies. Considering the price of $12 and $8, his total budget is exhausted. Great! Interesting, isn't it? So this is the equilibrium point for the consumer or family. He would gradually come to a consumption pattern defined by point E, where he derives maximum permissible utility and also works just within his budget. Properties of point E. At point E, the budget line touches the indifference curve once and only once. At any other point, as we have seen, the utility derived is lower than the indifference curve U3. Said another way, this point is where the budget line is at a tangent to U3. At any point beyond point E, the budget constraint is not satisfied either because the utility levels of the point are higher or because even if at a lower utility level, the consumer can't afford it. At any point below point E, neither is the budget exhausted nor is the utility level optimized. Let's summarize. The combination of good X and good Y that corresponds with point E is unique. It represents a tangency between the budget constraint and the indifference curve. The tangency is unique because at this point, the slope of the budget constraint is the same as the slope of the indifference curve. As discussed earlier, the slope of the indifference curve was defined as the marginal rate of substitution, and the slope of the budget constraint is the price of good X with respect to good Y, that is, relative price. Therefore, at the household's utility maximizing combination of good X and good Y, the price ratio must be equal to the marginal rate of substitution, or MUX divided by MUY is equal to PX divided by PY, which can be rewritten as MUX divided by PX is equal to MUY divided by PY.
Mom, if you don't mind, can you please explain how consumer has reached to the point of 9 packets of brownie and 4 packets of cookie with this budget constraint of $120?
Now, let me give you an example on how the equilibrium is achieved. Let's take combination of cookies and brownies for knowing how much quantity of each consumer will consume. After doing the test for finding out the utility for individual products, following tables for utility have come. As it is clearly mentioned in the table, the marginal utility of first unit of brownie is 85 units and the first unit of cookie packet is 70 units. To maximize utility, which should our consumer pick first? An initial guess would be brownies because it offers a higher utility. However, this does not factor in prices, which is an important determinant of which one should consume. Let's assume the price of packet of cookies is $8 and the price of a packet of brownies is $12 and the income of our consumer is $120. Economic theory suggests that the consumer would consume that thing whose marginal utility per price is the highest. Said another way, if consumer thinks how to get maximum satisfaction with each unit of dollar spent, then only he will achieve the maximum utility of all his income spent. So, he calculates marginal utility per dollar. Marginal utility per dollar for first unit of brownie is 7.0833 units per dollar, and for cookies it is 8.75 units per dollar. So instead of choosing brownie, the consumer will choose a packet of cookie because its marginal utility per dollar is higher. So now he has $112 left, 120 minus 8, and also has eaten 1 packet of cookie. Which of cookie and brownie should he consume now? For cookie, the marginal utility per dollar spent is now 7.875. Since he has already eaten 1 packet of cookie, his marginal utility for cookie has to decrease now, right? And for brownie, it is still the same as 7.08. Since the marginal utility of brownie per dollar spent is lower for cookie, he will go for second packet of cookies. Remember, the total income of consumer is $120, out of which he has now spent $16 in buying 2 packet of cookies. For the third bite, the marginal utility per dollar for the third packet of cookie, 6.875, is lower than the first unit of brownie. So consumer will select brownie this time and would spend incremental $12 out from his pocket. So overall spending till now is $28. Moving ahead, since the marginal utility per dollar for the third cookie is more than that of the second unit of brownie, the consumer will select the next cookie by spending $8 more from his pocket. Now, the total consumption rises by $36. What next? Second unit of brownie, marginal utility per dollar of 6 instead of fourth unit of cookie, marginal utility per dollar of 5.875. Total spending rises by $12 to $48. Next will be fourth and fifth packet of cookie, which raise the spending by $16 to $64. Next will be the third unit of brownie, which raise the spending by $12 to $76. Next will be 3 more cookies, which will bring the total spending amount to $100. Notice that at this juncture, marginal utility per dollar of brownie and cookie is same at 3, and coincidentally consumer is left with $20 in hand, which he will spend for 1 unit of brownie and 1 cookie. At this point, he would consume both and exhaust his budget too.
Very interesting.
So, the consumer will continue to eat things where he is getting higher marginal utility per dollar spent. There would then come a time when the marginal utility per dollar spent is the same for all the commodities. At that point in time, his total budget gets exhausted. Total of 4 brownies, 10 cookies are consumed, and the marginal utility per dollar spent also is the same. This is the equilibrium situation for the consumer.